Welcome back to the channel. Today we're tackling a super important concept in the world of databases, data partitioning. Now, if you've ever wondered how giant companies like Facebook, Amazon, or Google handle massive amounts of data without their systems slowing down or crashing, well, guess what? Data partitioning is one of the big secrets behind their success. But don't worry, we're going to break this down in a super simple way, using real-world examples to make it as easy as possible to understand. So let's dive right in. What is data partitioning? At its core, data partitioning is all about breaking down a large database into smaller, more manageable chunks. Think of it like organizing a giant closet into neat sections. Everything becomes easier to find, manage, and work with. Partitioning helps improve performance, scalability, and overall maintenance of your database, especially as it grows. Now, there are two main types of data partitioning we're going to cover today. 1. Vertical partitioning. 2. Horizontal partitioning. Let's start with vertical partitioning. Imagine you have a huge Excel sheet filled with tons of columns, but not every task you do needs all those columns, right? So, what if you could split it into smaller sheets based on just the columns you need? That's vertical partitioning. Let me give you a simple example. Say you have a users table with columns like user ID, name, email, password, and so on. Now, if most of your queries only need basic info like name and email, it doesn't make sense to load all that extra data every single time. What do? Split it. You can break the table into two smaller ones. User basic info. This will hold just the essentials like user ID, name, email, date of birth. User profile. This one stores details like user ID, address, and profile picture. By doing this, your database only fetches what it needs, making it faster and lighter. This is especially useful if different parts of your app need different sets of data from the same table. For example, when your login system just needs basic information like name and email, it will only query the user basic info table. On the other hand, when someone accesses their profile, you can fetch the profile details from user profile. Pretty neat, right? Now, let's move on to horizontal partitioning, or as it's often called, range partitioning. This is like dividing up your data based on rows instead of columns. Imagine you have a sales table that covers an entire year's worth of data. Instead of keeping everything in one massive table, you can split it based on the date, into quarters, for instance. Sales Q1, rows for January to March. Sales Q2, rows for April to June. If you need data for Q1, your query will only hit the Sales Q1 partition, making things a whole lot faster since you're working with a smaller, more focused data set. This is super useful for things like log data or historical data, where you usually only need a chunk of the data at a time. To sum it up, vertical partitioning splits a table based on columns, helps speed up queries by only fetching necessary data, may require joins when you need data from different partitions. Great for tables with lots of columns, especially if not all of them are frequently accessed together. Horizontal partitioning divides a table based on rows, like date ranges or regions. Perfect for large datasets where you only need a specific subset most of the time. Easier to manage because partitions don't overlap. Each one is self-contained. Choosing the right partitioning strategy can be a game changer, whether you're building a small app or working on a massive enterprise system. It can drastically improve performance, scalability, and maintainability. So, I hope this breakdown helped make data partitioning less intimidating and a lot more relatable. If you enjoyed this video and learned something new today, make sure to hit that thumbs up and subscribe for more tech content. I've got a lot more exciting stuff coming up, so stay tuned. Thanks for watching, and I'll catch you in the next one.